The introduction of the dry riser system. A dry riser system is a system of pipeworks and valves that run up through the building. The system allows firefighters to easily access water from each individual floor of the building. It consists of a vertical pipe with a water inlet on the ground level located on an external wall and outlet known as a landing valve, which are usually located in the dry riser cabinet on each floor. The dry risers are usually located in a firefighting shaft. According to the UBBL 1984, Section 230, installing and testing a dry riser system, there are 7 acts in the Section 230. Number 1, dry rising system should be provided in every building in which the topmost floor is more than 18.3 meter but less than 30.5 meters above fire appliance access level. Number 2, a hose connection should be provided in each firefighting access lobby. Number 3, dry riser should be a minimum Class C pipes with fitting and connection of sufficient strength which withstand to 21 bar water pressure. Number 4, dry riser should be tested hydrostatically to withstand not less than 14 bars of pressure for 2 hours in the presence of the fire authority before acceptance. Number 5, all horizontal run on the dry rising system should be pitches at the rate of 6.35 mm in 3.05 meter. Number 6, the dry riser should be not less than 102 mm in diameter in building in which the highest outlet is 22.875 meters or less above the 5 barrages pumping inlet, and not less than 182.5 mm diameter which are highest outlet in higher than 22.875 meters above the pumping inlet. Number 7, 102 mm diameter dry riser should be equipped with a 2-way pumping inlet, and 152.4 mm dry riser should be equipped with a 4-way pumping inlet. The building that we choose in this case study is a Wisma Sinlong. The building is located at Jalan Zabedah, Batu Pahat, Johor, with 13 floors. Now, how the operation of the dry riser? The firefighter fill the pipe with the pressure water by connecting the fire engine hose to the inlet on the ground level. Then connect hoses directly to the life-saving water supply on the floor nearest to the fire using the outlet valve connected to the dry riser. Connecting the hoses in this way is much quicker system for the firefighter. The hoses they use to connect on each floor are shorter and therefore lighter, and there are no requirement for run long heavier hoses up through the whole building. Using dry riser save time and ultimately save life. And now, the component of the dry riser. The dry riser inlet. The dry riser inlet are meant to facilitate the connection of a fire service water supply. At least 2 BS instantaneous male coupling are found in the cabinet. According under UBBL 1984, Section 237, 102 mm diameter dry riser should be equipped with a 2-way pumping inlet, and 152.4 mm dry riser should be equipped with a 4-way pumping inlet. And how it works? The fire crew will turn up and they will park the fire engine close to the entrance of the building. They will connect to the fire hydrant and feed that through to the fire appliances. That feed into the dry riser inlet and then pump water inside the building. And the firefighter connect into the end and then go into the building to fight the fire inside. The pipe work made up from galvanized steel pipe. The vertical piping span the entire height of the building, from ground level up or down through the different level. A 4-inch internal diameter pipe, a broader 6-inch internal diameter pipe. Under UBBL 1984, Section 234, all horizontal run in a dry rising system should be pitched at the rate of 6.35 mm in 3.05 meter. The last one, the dry riser outlet. The outlet point within the building allow firefighter to connect their hoses to the dry riser on each floor or level. A double or single BS instantaneous female outlet controlled by a gate valve makes up and pick up. The last one, the dry riser outlet. Outlet point within the building allow firefighter to connect their hoses to the dry riser on each floor or level. A double or single BS instantaneous female outlet controlled by a gate valve make up every outlet. As we know, the pipe that are fed into the building. The pipe works come through to the building, we feed the water in, connect the outlet by removing the cap, and connect their firefighting hoses to it. They charge the hose by turning on the wheel, and they guard an adequate water supply to go and fight the fire. The maintenance work. There is few maintenance work for dry riser system involve several key steps to ensure the functionality and compliance with the safety regulation. Visual inspection. Regular visual check to ensure the riser is free from physical damage, obstruction and sense of wear. Valve operation. Verify that all valves are operational, easily accessible and properly labeled. Pressure testing. Conduct pressure testing to ensure the riser can withstand the required pressure in case of fire emergency. Internal inspection. Periodically inspect the internal condition of the riser for corrosion, debris or blockage. Flushing. Flushing the system to remove any accumulated debris and ensure clear passage for water flow. Seal check. Inspect seal and gasket for any sign of deterioration that could affect the integrity of the system.